Okay, I am going speedy boy on this one because I have class here soon, but I wanted to help out Ada. Man, I wrote this poorly. So, we proved that polynomials in an abstract sense with this division algorithm work, which is that f of x here is going to equal g of x times something, we're going to call that q of x, plus a remainder. Wow, okay, plus a remainder. So we can use long division to figure out what that will be. We set up our long division. We have our dividend, I believe is the name. No, wait, divisor? I think this is our divisor and our other one's our dividend. Not sure. But the small one goes on the outside. And the big one goes on the inside. And now what we have to do is ask ourselves, just one by one, what do I have to do? What do I multiply x squared by to then get rid of the x to the fourth? Well, x squared times x squared gets me x to the fourth. And so then I go and I multiply this against my polynomial here. And that's going to get me x to the fourth minus 2x cubed plus 3x squared. Now, what he didn't put is these handy parentheses, and this is the best way my brain can latch onto it. I should do a straight line. X to the fourth minus x to the fourth gets you that 0. Perfect. So this is just like 0. Now we have negative 2x cubed. So this is going to be positive. So we're going to get a negative x cubed. I hope that makes sense, right? Negative 3 plus 2. Boom. And then we're going to have positive 2x squared minus 3x squared. That's going to get you a minus x squared. I think, I hope, pray. Great. Now, what do I multiply x squared by to get negative x cubed? Well, that's going to be negative x. Right now, whenever I do long division, I don't focus on the signs. I just make them match. Because what I want is a negative x cubed down here. I don't want a positive because I'm going to be subtracting eventually, right? Oh, and then I need to pull down the 4x, sorry. Plus 4x. So I have negative x, and that gets me a negative x cubed. And then I'm going to have a positive 2x squared, right? And then I'm going to have a negative 3x. So these become 0. That becomes negative 3x squared because I'm subtracting the 2. And then I'm going to end up adding the 3, so that becomes 7x. Now, as like a quick pause, notice here I have a 7, and we said we were working in Z5. We're just going to, we don't have to do any of the simplification until the end. In fact, I find that it's probably, unless it gets really big, it'll be less complicated to simplify. Like if we had like 153 something, it'd be really easy to simplify that to 3 and then do it later. But for this purposes, right now, that would just create confusion. And I'm going to pull down the minus 1. And now I'm going to ask, what do I multiply x squared by to get negative 3x? That's readily apparent. That's going to be negative 3. And I'll get negative 3x squared. I'm going to put my negative on the outside so I don't forget it. I don't like where I'm pulling an eta. And then I get positive 6x. And then I get, uh-oh. Did I do something wrong? I hope not. No, maybe not. Minus 9. I get my 0. I get a negative 13x. And I get a plus 8. Cool. We can't go... I must have done something wrong. What did I do wrong? 4x minus 3. Is that minus 3? Yeah. Interesting. Okay. Either way. So this is my q of x, right? If I multiply this times g of x, and then I add my remainder, I'll end up getting f of x. Now, why is that wrong? Hold on. I feel stupid right now. Yeah, wait, why is that a positive 6x? Oh, it's because I am This is a positive 6 being subtracted to a positive 7. So that's just going to be an x. Yay! X plus 8. That makes sense. And then I'm going to have my remainder, which is x plus 8. But I'm changing that 8 to a 3 since we're in Z5, right? Because 8 minus 5 equals 3. And then that's over our, what did I call it? A divisor. I still don't know if that's right. But this means that f of x equals our divisor, x squared minus 2x plus 3 times x squared minus x plus, x squared minus x minus 3. So this is g of x, right? This is our q, and then we have to add x plus 3. Notice I'm not doing the fraction thing because that's just for the long division. But yeah, so if we were to do all this multiplication and then add, you'll notice here we would get a negative 9. Is that right? Negative 9. And then you add the 3, that's negative, I'm just checking the constant right here. You get negative 9 plus 3 equals negative 6. But in mod 5, that's negative 1. And we have a negative 1 in f of x. So it looks like we probably did it all correctly. But yeah. Oh, and then I should probably label this as r of x. So I hope that kind of makes sense. I can do another problem. I just can't do it currently because I got to go to class. But yeah.